Alright, let's take a look at sequences 3.8 and 3.9. So on the first one, how are arithmetic and geometric sequences similar and how are they different? So if you have that frame, take a look at that. That should help you figure out what the similarity is, what the differences are. Okay, differences should be a lot easier. Similarities might be a little bit more troubling, but there are some. So take a look at that. We'll talk about it in class. Okay, now this is some of the more difficult stuff. We're trying to figure out, we've got an arithmetic sequence, so we know that we should be adding and subtracting. Find the missing terms. Okay, now table 3 should be the easy one. Okay, because you've just got to find the number that you can add here and add here to get those. Okay, but it becomes a bit trickier when we're dealing with multiple holes in there. Okay, so we start at 2 and we're getting up, this is kind of the way you should think about it. I'm not going to worry about doing number 3. You guys can do that on your own. So we won't do number 5. We'll take a look at 4 and 6. So I make a jump from here, and then a jump from here, and a jump from here. Okay, so basically I'm adding a number 3 times. That's what we're looking at. Okay, so let's find the difference between 2 and 26. This is the first step. Okay, so 26 minus 2 gives us 24. Now we've got to split that 24 up into 3 different pieces. In other words, we're going to divide 24 by 3. If we do that, we get 8. Okay? So, what that should mean is that we're adding 8 each time. So let's test it out. See if we did it right. So, 2 plus 8 is 10. 10 plus 8 is 18. Is 18 plus 8 26? Yes, it is. There we go. So 10 and 18. Okay, so table 6, we kind of got the same thing going here. So we're making 1, 2, 3 jumps from 16 to 4. So now, what's the difference between 16 and 4? 16 minus 4 is 12. We made 3 jumps, so however many jumps you take, that's what you divide by. 12 divided by 3 is 4. Now because we're going down, we're going to be subtracting 4. So 16 minus 4 is 12. 12 minus 4 is 8. 8 minus 4 is 4. 4 minus 4 is 0. So there we go. That's all we got to do. So because, we've got to pay attention to how many steps is it taken, and then divide, find the difference, divide that by that many. Okay? Alright. Now on these next ones, you're determining if the sequence is arithmetic, geometric, writing a recursive, and an explicit equation. Okay? So, we've got quite a few of those. And let's take a look at, I'm going to do number 9, I think. I think you guys should be able to try 7 and 8. I'm going to try 9. We'll take a look at 10. Yeah, 9 and 10. So, we've got 60, then to 30, then to 15. So I could start out thinking, well, maybe it's arithmetic. So if I subtract 30, will that get it? No, 60 minus 30 is 30, but 30 minus 30 isn't 15. So I'm going to have to multiply or divide. Well, 60 to 30 I can divide by 2. Does 30 divided by 2 equal 15? Yep. 15 divided by 2, does that equal 15 over 2? Yeah, it does. So we're geometric. Now, you've got to remember, we don't like to think in terms of dividing by 2. We really like to change it to multiplication. So if I had a problem like this, 1/2 divided by 2, we couldn't do it. We would have to change this to multiply, make that a fraction, and then get the reciprocal. That's how we deal with division of numbers, okay, when we're dividing with fractions. So dividing by 2 is the same as timesing by 1/2. So we think about our recursive equation. Well, where did we start? We always have to have that. So we started at 60. Now we do our equation. F of n equals f of n minus 1, and we're timesing by 1/2. You could put divide by 2. That would still work. And remember, that whole piece is our recursive equation. Now for our explicit equation, we started out like this. Let's use f of x this time. You could use y. So f of x equals our starting number, which was 60. And then what did we do to 60? Well, we times it by a half. How many times do we times it by a half? We don't know. We have our variable. Because it's geometric, I know my variable becomes an exponent. Okay? So, let's take a look at number 10. Now we got a pattern going on here. Let's kind of dig a little deeper. So we start out with 1. At 0, we have 1 black. Next, we have 2. The next, we have 4. Okay? So, how do we get from 1 to 2? We add 1 or we multiply by 2. 2 to 4. We can't add 1. We either add 2 or we multiply by 2 again. So, we're geometric. We're timesing by 2. Okay? So, I think I'll let you guys deal with that one. I wanted to do an arithmetic one, actually. Let's take a look at 7 then. I think from there you can get the recursive and the explicit. So, 5 to 9, we're adding 4. 9 to 13, adding 4. 17, we're adding 4. So definitely arithmetic. Now recursive, where did we start? We started with 5. Then our next term takes our previous term and we add 4 to it. So our explicit equation, where did we start? Started with 5. What did we do to it? Added 4. How many times? X amount of times. We multiply because it's arithmetic. Okay, there we go. Now, if we look at the 3.9, we've got a sequence that's given us a starting point, telling us how it's growing, and we're going to find it for each term. So it's think of this as if we were making a table like this. Okay, and this is the output, and that's the input. Okay, they told us f of 1 equals 2, so I write 2 here. It's like I'm writing 2 there. Common difference is 10. What does that mean? It means we're adding 10 each time. Okay, so every time I add 10. So 2 plus 10 is 12. Plus 10 is 22. Plus 10 is 32. Plus 10 is 42. Okay, just the same way as if I were completing that table. Now, for a geometric sequence, we've got g of 1 equals 2. So they start out at the same place. Common ratio of 3. Common ratio means we're timesing by 3. Just the same way as if we made this table, 1, 2, 3, 4, 5, and so on. We start at 2, and then we're timesing by 3 each time. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is a number. Okay. 54, 2, 54. 54 times 3 is 150 and 12. 162. Okay. So then it asks you this question, which value do you think will be more, f of 100 or g of 100? Okay, why? Well, look at how fast they're growing. Here, we're tripling. Here, we're just adding 10. How's that going to get bigger? Well, hopefully, what you picked was this one. Why is that one getting bigger? Well, because it's traveling quicker. Okay, in just 5 steps, we're already way above, and it's just going to keep getting bigger and bigger. Okay, because it's growing, it's tripling every number instead of just adding 10. It's tripling every number. Okay, let's take a look at another one like that. So same idea. Where do we start? Start at 20, and we're adding 10 each time. So 20, 30, 40, 50, 60, and so on. Then geometric, we're starting at 2, so starting even smaller, and timesing by 2 each time. So 2, 4, 6, 8. Whoa, that wasn't even timesing by 2. 8, 16, 32. So now this one might be harder to see. You may think that, oh, well, f of 100 is obviously bigger. But you got to remember, if you're just adding by 10, your numbers are only going to get 10 more. So if you get clear out to f is 100, you may be like clear up to 1,000 even, but it's only going to be 1,010, 1,020. Whereas if you get up to this one, even if it were at 1,000, you were timesing by 2 and it would go to 2,000, then to 4,000. Can you see as numbers get bigger, timesing by 2 will get them bigger. So your answer would once again be the geometric one. Okay? Now, the last thing to look at is how these geometric sequences grow. Okay? So, let's take a look at 7 and 9. These ones are a bit more difficult to think through. Okay? So, once again, we've got to see how many times are we jumping. We're jumping 3 times. So we're going to times something by there 3 times. So now what we have to do is take 54 and divide it by 2. We need to see how many pieces, how it is split in half, because we're multiplying, so we got to think of doing the opposite. 54 divided by 2 is 27. Now comes a really weird part. Okay? If you only have 2, you need to cut that into the pieces that what times what is 27. That's essentially what you're saying. If you have a calculator, it has a fancy function called the cube root. The cube root tells us that. And if you put it in there, it'll spit out 3. If you didn't, you'd have to try to figure that out by saying, 3 times 3 is 9, times 3 more is 27. So we should be timesing by 3 each time. So 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. Okay, what about number 9? We're jumping 1, 2, 3, 4 times. So I go 324 divided by 4 to get 81. Okay, then we're going to take the 4th root using a calculator to split it up into which 4 pieces times together equal it. And once again, it's 3. So we're timesing by 3 each time to figure this out. So 36 times 3 is 108. Times that by 3 again, and we get 324. So a little crazy, that one, but it has to do with these splitting them up into their different pieces. Okay? So, there we go with that.